Now what we're doing today is we are going to figure out how to draw force diagram equations for it, for a car that is going around a turn. Alright, so hold on a second, we're having technical difficulties. Alright, we are going to do a point that is going to represent the car. So this is the car. This is going to be the weight of the car. And as you know, that's going to be mg. Now, the same amount is going to be pushing upward. Let's see. Yay amount. And that will be force N for normal force. We are also going to include one that is like that. And that will be called the centripetal force. Now we are going to write summation equations for this scenario right here. And this is going to be very important for you to get these right on the test. So we're going to have a summation of x. So we're going to write everything that we see that is in the x direction. Now we're going to notice that this one, f sub c, is in the x direction, and it's positive. Now since the car is going to be accelerating in that direction, it is going to have to be equal to the mass times the centripetal acceleration. Now the other one would be f sub y. Now the ones that are in the y direction are here and here. And we're going to have n pointed up in the positive y direction, and in the negative direction we're going to have mg. Now since this car is sitting right here, we don't have any acceleration in the vertical direction. So that will equal 0. So these set of equations are going to be important for you to have for the test. All right. Now we're going to do this. We're going to make another equation that has been found to be true. And not only is it going to be a little bit fun, it's going to be a little bit useful. All right, and this one is going to yield this. Now, since this is n, we are going to substitute in f equals mu mg. And then we will proceed to show that F, which is the friction, is going to be or is not going to be, depending on what the situation is. If it's on ice, it's not going to be sufficient, probably. If it's on loose gravel, it won't be sufficient, probably, to keep the car on the road. And to test this, we will say is the centripetal force, which is going to be that, and that would become mv squared over r. And then we will proceed to say if F equals C, F sub C, that means that these two can be set equal to each other. And we will have this equation right here. Now let's add another page here. Now I'll write down the same thing we just had up above. Whoops. Hold on a second. Okay. Mu right there. We'll switch it right now. Mu M G. And we need to know whether or not this is true. So we are going to do this. Mu, we're substituting now. Mg, if that is equal to mv squared over r. Now you'll notice that the m's will cancel out, and we will have this. Now, if mu, right here, is sufficient to hold us on the road, that will be a characteristic of the road. And if you find this to be true, it would be v squared over rg. So if this number right here is big enough, then this will stay on the road. The car will stay on the road. Okay, and that pretty much wraps this one up. And we'll see what happens here.